Okay, good day. This is dual enrollment pre-calculus. I'm Mr. McCully, and this is lesson 20, graphing sine and cosine functions. Let's get right to it. Today we're going to talk about the graphs of the basic sine and cosine functions, and then we're going to talk about some transformations and translations. These relate all the way back to our first lesson of the year, and you will see some distinct similarities to what we did with our transformations and how amplitude and period are going to change the shape of our sine and cosine functions. As always, we're going to keep in mind the unit circle because we're going to be talking about what I call quarter turn values. And when I talk about quarter turn values, I'm talking about quarter turns around the unit circle. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are going to be very important to us. And we see that right here in this next slide. If you notice, 0, pi over 2, pi, 3 pi over 2, and 2 pi, they are important points because they're maximums, minimums, and these center line points. Same thing with cosine, 0, pi over 2, pi, 3 pi over 2, and 2 pi. These are real important points because they're giving us our maximums and minimums. And so when we graph these points, we'll just connect the dots in between the rest, knowing that it's a smooth curve. And so this note here that I have at the bottom, it says when setting up the process of graphing, we're going to set up these intervals, and we're going to plug in those numbers inside the functions, and they must reduce down to these quarter turn values: 0, pi over 2, pi, 3 pi over 2, and 2 pi. If you say that you're taking the sine or cosine or tangent or whatever of something other than values in this list, then you have made a mistake and you need to go back. So our generalized sine and cosine functions look like this, and y equals d plus a times the sine of bx minus c. And so d, you'll realize real quick that this d is going to be a transformation up or down. So if d is positive, you move it up. If d is negative, you move it down. A is the amplitude, and we'll recognize, actually the absolute value of A is the amplitude, but we'll recognize this as a vertical stretch up or down. The reason that the amplitude is listed as the absolute value is because if A is negative, you could have a reflection in the x-axis, and the amplitude is regardless of that reflection. But we will still have to take that into consideration when we do the graph. When I take 2 pi, the general period, and I divide it by this b value that's out in front of the x, we'll find the period of that function. If b is equal to 1, then this c value is a left-right transformation. But if b is not equal to 1, this is where it becomes probably the most difficult of the problems. When b is not equal to 1, then the combination of b and c is a stretch and a left-right translation. So it's a horizontal stretch and a left-right transformation. And we'll talk about how we're going to deal with that here in the next slide. Now the next slide here is just a list of steps that you're going to follow. And I've got 4 examples, and so I'm going to follow this list pretty religiously as we go through. So first thing we're going to do is find the amplitude, then we're going to find the period and make our quarter turn divisions. And then we're going to say, we're going to look at this c value. If c is equal to 0, we're just going to graph the period starting at the origin. But if c is something other than 0, well, our quarter turn values are not going to start at the origin. And so what we're going to do is we're going to set what's inside there, this bx minus c equal to 0, and then we're also going to set it equal to 2 pi. And when we solve for x in both of these, what's going to happen is that those two x values are going to end up being the endpoints for our first period, and we'll move on from there. Once we've set up all the values, we're going to plug in points along the period, and then we're just going to connect the dots along the curve. So what does that look like? Well, let's start with a simple one where we have a vertical stretch and talking about amplitude. And so this thing is going to be very close to our general cosine function, except it's going to have an amplitude change, which is a vertical stretch. And so if I say, what is the amplitude of this one? The amplitude is the absolute value of that value here right out in front, and so it's the absolute value of 3, and so we say that our amplitude is going to be equal to 3. All right, so how does that change this general graph? Well, the way it changes it is it's going to move that value up to 3 and down to -3. We have no other changes that we have to deal with. My period, since there is no value in front of the x, it's just the 2 pi. All right, so what I can do is I can start here at 0. I can go over to 2 pi, and we're going to do 2 periods, so I'm also going to go over, not to 2, but I'm going to go over to 4 pi as well. And so I've talked about these quarter turn values. So the way that we get those quarter turn values is I'm going to take that original period, I'm going to divide it in half, and then I'm going to divide each of those into halves, and so now I have 4 quarters. All right, I'm going to do the same thing over here. All right, so I've got my quarters. All right, so halfway between 0 and 2 pi is pi. And then halfway between 0 and pi is pi over 2. So from 0 to pi over 2, I am now counting by pi over 2. So I've got 1 pi over 2, 2 pi over 2 is pi, 3 pi over 2 is doesn't reduce, but 4 pi over 2 reduces down to 2 pi. 5 pi over 2, 6 pi over 2 reduces to 3 pi. 7 pi over 2 can't be reduced, but 8 pi over 2 reduces to 4 pi. Now, because those numbers matched up, I feel confident that I've set these values up correctly. All right, so I have no values for B and C, so I can just start plugging in points, and they're clearly those quarter turn values, so I don't have to worry about it. All right, so I'm plugging values in. 0, the cosine of 0 from the unit circle is 1, and so the cosine of 0 is 1. 1 times 3 is 3. That is my first point. Pi over 2, the cosine of pi over 2 would be 0. So 0 times 3 is 0. The cosine of pi, we know to be -1 from the unit circle, times 3 is 3. The cosine of 3 pi over 2 is once again 0. The cosine of 2 pi is 1. And because we've set everything else up right, now that we've gone one full period, we can just copy that period over. So we started at this top one, so we go down, and then we go to -3, we go up, and then we go up here. And so now all I got to do is connect the dots, and there is my simple cosine function. All right, so let's take it up a notch. We dealt with amplitude. Let's do a change in period. So here we have y equals sine of 2x. So going through those steps again, right here, start with finding the amplitude. So my amplitude, well, that is the absolute value of 4, which again is 4. And so instead of going from +1 to -1, I'm going to go from +4 to -4. And to find the period, we look at the value that's in front of that x, that b value in front of the x, and just divide it by, I divide it into 2 pi. So my period is going to be 2 pi over 2, which is going to leave me with just pi. So my period is just pi. Now because again, there's no c value here, there's no left-right shift, we just changing how soon the function repeats. So if the period is pi, I'll start at 0, and then we'll do one period at pi, and then we'll do a second period at 2 pi. And so I have to go through and get my quarter turn values set up. So I'm going to divide that into half, and then divide each of those into half, divide this one into half, and then both of those into half. So now I've got quarters. So halfway between 0 and pi is pi over 2. halfway between 0 and pi over 2 is pi over 4. So now we're counting, because we started at 0, we're counting by pi over 4. So I've got 1 pi over 4, 2 pi over 4 reduces to pi over 4, 3 pi over 4 does not reduce, 4 pi over 4 reduces to pi, 5 pi over 4 does not reduce, 6 pi over 4 reduces to 3 pi over 2, 7 pi over 4 does not reduce, 8 pi over 4 reduces to 2 pi, which is what we have there. So now I feel confident about that I've set this up correctly. Now again, and this is where, let's go back up to here, where I say if you plug in those numbers and it doesn't reduce to a quarter turn, you've made a mistake. Now these aren't our regular quarter turn values, but what happens when I plug this into here, and I'm just going to do this, I'm going to do this first one, actually we'll do 0 first because that's where we want to start, but 0 times 2 is 0, the sine of 0 is 0, times 4 is 0. But it becomes more important when we do this pi over 4. So let's just kind of plug that in there. Y equals 4 sine 2 times pi over 4. Well, what I said is that what's inside here has to reduce to what we would call those quarter turn values. And so I go y equals 4. Well, this thing is the sine. 2 times pi over 4 is 2 pi over 4, but that fraction reduces. 2 over 4 reduces down to a half. Half times pi, y equals 4 sine of pi over 2. Now that is a quarter turn value. There's nothing else I can reduce inside the parentheses, so I am taking the sine of one of those quarter turn values. All right. So the sine of pi over 2, we know to be 1. 1 times 4 is 4, so we go in there and we put that in there. All right, so let's do the rest of these. These aren't too bad. Pi over 2 times 2 is just pi. The sine of pi is 0. Times 4 is 0 also. So 3 pi over 4 times 2 is 3 pi over 2. The sine of 3 pi over 2 is negative 1. Negative 1 times 4 is negative 4 pi. Pi times 2 is 2 pi. The sine of 2 pi is 0. Times 4 is still 0. And we see that we've completed one period. So since we've matched all those values up, we can just go through and copy. So pi over 4 and 5 pi over 4 will match up. Pi over 2 and 3 pi over 2 will match up. 3 pi over 4 and 7 pi over 4 will match up. And pi and 2 pi match up. And we've got a nice, pretty curve that looks like this. And we're done. All right, halfway. Here we go. So here we have a vertical shift. And so we're adding a little bit onto it. So we're kind of adding a value, a d value here, but we're putting it at the end. So let's talk about this thing. So we start the same way. We start going through that list of steps. Find the amplitude first. So my amplitude is going to be absolute value negative 2, which will give me a 2. My period is, and again, you take the 2 pi and you divide by the value that's in front of the x. So we're dividing by pi this time, and so the pi's cancel out, so my period is 2. So I got a whole number period, and then I have no left-right shift, but I do have a translate 3 units up. So the way that I do these transformations 3 units up is what I'm going to do is I'm going to put this center line, and change the center line from y equals 0 to y equals 3. So I'm going to go up here to 3, and I'm going to put a mark at 3, and I'm going to put in this dotted line here. And this dotted line is going to represent the center line that's halfway between the maximums and minimums, okay? And since my amplitude is 2, it's going to go above 3 by 2 units, so that'll be a 5, and it'll be below the 3 by 2 units, so I get a 1. All right. Again, there's no left-right shift, so I can still start at 0. And since my period is 2 units, my first one, I'm going to put a 2 over there, and then I'm going to put a 4 over there, 2 more periods. I'm going to cut it into my quarters again by dividing each section into halves. And so halfway between 0 and 2 is 1. Halfway between 0 and 1 is a half. This time we're counting by halves. So 1 half, 2 halves is 1, 3 halves does not reduce, 4 halves is 2, 5 halves does not reduce, 6 halves is 3, 7 halves doesn't reduce, and 8 halves is 4. So we're good there. Alright, so let's plug in some values. Start plugging in. 0 times pi is 0. The sine of 0 we know to be 0 times -2 is still 0 plus 3 is 3. So I put a point there. Half. Half times pi is pi over 2. So we've reduced it to one of those quarter turn values. I'm happy. I think we've done that right. The sine of pi over 2 is +1 times -2 would make it -2. Plus 3 is -1, or is +1. 3 pi over 2. All right. Wait. Oh, I did a half. I put that at the wrong spot. Sorry. Put that in the right spot. There we go. 1. 1 times pi is pi. Again, a quarter turn value. The sine of pi is 0 times -2 is 0 plus 3 is 3. 3 pi over 2. 3 pi over 2 times pi is 3 pi over 2. The sine of 3 pi over 2 is -1. Times -2 is +2. Plus 3 is 5. Plug in 2. 2 times pi is 2 pi. The sine of 2 pi is 0. Times -2 is still 0. Plus 3 is 3. And I've got my -2 here, or my 2 here. It's a little bit off. So let's just make that even it out just a little bit. All right. And so now I've completed one period, and since I feel real confident in my values, 0 and 5 and 2 match up. A half and 5 pi over 2 should match up. 1 and 3 should match up. 3 over 2 and 7 halves should match up, and then 2 and 4 should match up. And so I draw in this nice, pretty curve. Matches the point, and we are finished. It is page 300, Sparta! It's a joke. I'm sure you're all laughing real loud now. Page 300, number 52, graph the trig function by hand. So now we have something that's a little bit different. We have this plus extra, so it's going to look, we have this c value that we have to deal with. So now we're coming back where we have some value for c that's not equal to 0. And so what we're going to end up having to do is set that expression equal to 0 and equal to 2 pi to figure this out. Now, this is a fairly simple one, but we're still going to go through all of the process that we had before. So the amplitude is absolute value of 3, which is 3. My period, I don't know why pi, P-E-R-I-O-D. Since that value is 1, it's just 2 pi. Well, 2 pi divided by 2 is, or divided by 1 is 2 pi again. And there's no up, down. All right, so since there's no up-down translation, we still have this that we have to deal with. And so the way that we're going to deal with it is we're going to take this x plus pi over 2, x plus pi over 2, and set it equal to 0, and then x plus pi over 2 and set it equal to our endpoint 2 pi. All right, and so I solve this, I get x equals to -pi over 2 and x equals to 2 pi minus pi over 2. Well, we got another step, so we ask ourselves, how many halves are in 2? Well, there are 4 halves in 2. And so this new endpoint is going to be -3 pi over 2. Now, these and turn out to be fairly easy, simply because our period is 2 pi. But even if there's another number here that's different, you still set it equal to 0 and 2 pi to get those values. So let's do the graph here. Now we are starting. These are my new endpoints. So let's do that. New endpoints, ENDPTS, of the first period. X equals negative pi over 2, it's negative, and 3 pi over 2. This should be a positive here. I don't know why I put a negative there. Hopefully I just move my hand. All right, so negative pi over 2 here, and 3 pi over 2 there. And since the period is 2 pi, and we already know that there are 4 pi over 2, or 4 halves in 2 pi. If I go 4 halves plus 3 pi over 2, I'll get 7 pi over 2. All right, so halfway between those two, and then make that in half. Halfway between those two, this 0 is going to be halfway in between those two. And so I'm counting by pi over 2. So I've got negative pi over 2, I got 0, I've got 1 pi over 2, I've got 2 pi over 2, which is just pi, 3 pi over 2, 4 pi over 2 is 2 pi, 5 pi over 2 doesn't reduce, 6 pi over 2 is 3 pi, and then 7 pi over 2 is that. And because my amplitude is 3, we go up to 3, we go down to negative 3, we have no up-down shift, so the x-axis is our center line. And so I start plugging in some values. So negative pi over 2 plus pi over 2 is 0. The cosine of 0 is 1, times 3 is 3. I plug in 0. 0 plus pi over 2 is pi over 2. The cosine of pi over 2 is 0, times 3 is 0. Pi over 2 plus pi over 2 is pi. The cosine of pi is negative 1. Negative 1 times 3 is negative 3. 3 pi over 2 plus pi over 2 is 2 pi. The cosine of 2 pi is 1. No, I'm sorry. Yeah, it's 0. Oh, I put this in the wrong spot. I apologize. Let's get it right here. Pi plus, so one more time, just to correct my mistake. Pi over 2 plus pi over 2 is pi. The cosine of pi is negative 1, times 3 is negative 3. When I go to pi here, this one, pi plus pi over 2 is 3 pi over 2. The cosine of 3 pi over 2 is 0, times 3 gives me 0. Now I feel confident. There I go. Corrected my mistake. So 3 pi over 2 plus pi over 2 is 2 pi. The cosine of 2 pi is 1, times 3 is 3. And that is one period, and so now I connect matching points. So at 0 and 2 pi I have a matching point. At pi over 2 and 5 pi over 2 I have a matching point. At pi and 3 pi I have a matching point. And then 3 pi over 2 and 7 pi over 2 I should have a matching point. And connect my dots. And we are finished. All right, I'm sure we'll have to do some more examples in class, but that's all I have for this particular lesson. So let's hit our Star Wars fun fact of the day. James Bond himself, Daniel Craig, has a small cameo in The Force Awakens where he plays a stormtrooper who is Jedi mind tricked into releasing Rey from the evil clutches of the First Order. That's all I got. Have a good day. Bye.